Bismillahirrahmanirrahim, student. I am Amjad from this institution. Mathematics is learning for metric capacity and PhD. Students, I hope all of you are fine. I am also alhamdulillah fine. Student, today I have taken a topic for you that you can see on the whiteboard. I have written, and the first time you can see that I have written important formulas of derivative for class 12 and DAE code 212. You can easily understand from this line that our today's class contain on the subject of the class 12th math and the class DAE, Diploma of Associate Engineer code 212. In the second line, student, you can see that I have written notation used for derivatives, or these notations are d by dx. We can use to find the derivative d by dx and f dash of x, or d by dx of f of x, comma f dash of x, like this. And in place of this d by dx, we can also use in mathematics for derivative capital D x f of x for this. In the third line, you can see, student, we are finding the formulas for this derivative. As in the third line, here is the written d by dx of c. C stands for constant term, and the derivative of the constant term is always 0, like this. Here we write 0, and after this you can see I have written this example. E.g. stand for example, the derivative of the 5 is always 0. In the next line, you can see that I have written d by dx of c of x. It means that one is the constant, and with this constant there is a variable. Here you can see derivative of the c of x. So derivative of the constant with variable is always here, just like c, and the derivative of the x. It means we will take the constant term before the variable, and just we take the derivative of the variable of this x. In the next line, the derivative of the x power n. In this type, we just take n as a first, and we subtract 1 from this power, like this, n x n minus 1. And if we want the derivative of the function of the x, we can understand from this example, but we first write the formula for this. The derivative of the function of x is raised to the power n is always equal to the, here n is first, like this, and then subtract minus 1, or you can say from this n we subtract just 1, and again we take the derivative of the function of x. Here is a little bit difference, that if there is a simple x, we just write x n minus 1 and n before the x. And here is another, that f of x is the function. Then we again take the derivative of this f of x, and the example of this function of x is this. Suppose we have this example, a minus x whole power 1 by 2, and in this example a minus x is the function of x. So we take the power first and then subtract 1 from this power and take the derivative of this a minus x, which is over function, example of the function of x. And the next, you can see that I have written here x raised to the power r. Its mean we can also use small r. So this example is just like this. Just write this example. Just write r x r minus 1. This is the same like this. Now you can see that I have written derivatives of sum and difference. If our questions are of sum or difference, how we can solve? You can see that I have written that d by dx of f of x plus g of x, or generally we can understand from this u plus v. In our books or in general term, teachers are using these terms u plus v, the derivative of the u plus v, or you can say that the derivative of the function of x plus g of x, or you can say that f of x or g of x. So just apply the derivative separately to these terms f of x plus derivative of the g of x, and here another is of the just like the example of the difference. If there is a minus, it means this is the example of the minus. So we just apply d by dx or the derivative of f of x, and here we just put minus d by dx of g of x, just like the above. Difference is just this, that we have put here minus. In the next example, or you can say in the next line, I have written product rule. Student, this is also an important rule, and we must remember in future question we use this formula. Or you can say that d by dx of f of x g of x. It means these two things are multiplying, and when two things are multiplying, then we use the product rule in derivation. Now I am writing. In general, teachers are using the term u v. So we can write u on the f of x and d by dx of the g of x, here bracket, and plus is this sign of principal and g of x, and the derivative of f of x. We have got this first as it is, derivative of the second, plus this is the sign of the principal, and g of x, it means second. Second is as it is, and the derivative of the first. Or we can write this formula like this. If in some books in the future, or you can say that in the higher classes, these things can be used in your future classes, for higher classes. So if there is a f dot g, we can consider this just like this, that this thing is just like this product rule. So we can write this like in such a way that f is as it is, and the dot derivative of the g plus is the sine of principal, and after this g is the same and the derivative of the f. So it's mean that we can denote this derivative with this slash. You can see I have written in front of you. If here is written slash, we can consider that we are finding our derivative. For coefficient rule, student, I am writing. You can watch in front of you. I am writing. Here, just put here one line. Take the derivative square of this denominator. Here is a g of x is the denominator and f of x is the numerator. So take the square of this denominator. The denominator is same here and the derivative of numerator, which is of f of x here. And here minus is the sign of principal, and after this the numerator is same and the derivative of denominator. Here we can also use u upon v. Here u, and in place of this we can also do, if we are using u upon v, here it's mean v square, v is as it is, and the derivative of u minus u is as it is, and the derivative of v. And for this formula we can also use f upon g whole dash. Here square of the g is same dot derivative of the f minus is the sign of principal, and after this f is same and the derivative of g. It's mean we can here use, if here v, here v is the same, and here derivative of the u minus f of x is over u, and the derivative of the v. It's mean in the language of u upon v, we can write this formula: v square, v is as it is, and the derivative of u minus is the sign of principal, and after this minus, u is as it is, and the derivative of the v. Student, this is regarding the basic formulas of the derivatives, and you can see that here is a trigonometric function. Here are trigonometric functions. For trigonometric functions, I am writing so that because I have already written and I want that we will complete this. Student, the derivative of the sine x is cos x, and the derivative of the cos x is minus sine x, and the derivative of the tangent x is secant square x, and the derivative of the cotangent x is minus cosecant square x, and the derivative of the secant x is secant x, tangent x, and the derivative of the cosecant x minus cosecant x cotangent x. Here student, I have written all these formula in front of you so that you can understand that I know. If you want to know, then you have to practice these formulas, because once you are doing the job at your own, it's important that you must try again and again to learn these things. Better is this, you speak out in front of some people, just like me. I am speaking in front of you. It's mean I am repeating 100 times in front of the all the peoples. If you do like me, inshallah, you will learn very easily. Student, up to here today is our class. Inshallah, in future lectures we will discuss about the inverse trigonometric functions or the derivatives of the you can say that the logarithm functions. Inshallah, in future we will discuss. Thanks a lot.